Hello, welcome to Lab 3 seasons. We're going to talk about the zenith. We're going to talk about Earth's rotation and orbit and the axis of the Earth and how these all affect seasons. So first, we're going to talk about the heat transfer that the sun transfers to the Earth. So radiation is the process by which wave energy travels through the vacuum of space or through a physical medium such as air or water. So as you can see here, we have this hot cup of hot chocolate, which is represents the sun, which is this hot mass, and then it's going to transfer its heat into this ice water bath, which is the Earth. So it's going to warm up the Earth as the sun loses heat. But because the sun has so much heat and it is constantly creating heat through fusion, it's going to keep producing heat for the Earth. So the sun's light is a broad spectrum of wavelengths. It's mostly short wave radiation, with ultraviolet as the shortest, and then visible, and then into infrared, microwaves, and then long radio waves. As you can see, the radiation intensity of visible light from the sun is the greatest, with infrared and UV light the next greatest. And then as you go farther and farther to the right, the wavelength of long radio waves and microwaves is greatly decreased in the emission from the sun. But then once you get on Earth, the atmosphere radiates long wave radiation, and we'll talk about that more next week, but just keep that in mind, the difference between short wave radiation and long wave radiation. So the solar elevation is the angle at which the sun or the light waves hits the Earth. So when you have a low solar latitude or altitude, you're going to have a longer path through the atmosphere and it's going to be more diffused. But then at the equator, you're going to have a high solar altitude and it's going to have a pretty short path through the atmosphere. So it's going to be more intense. So Earth's orbit. Earth's orbit is not completely circle, it's an elliptical. So it's going to have a perihelion, which is the shortest distance from the Earth to the sun. That's going to occur in January. And then the aphelion is the greatest distance between the sun and the Earth. And that's going to happen in July. So that's going to also affect how intense the solar radiation is coming from the sun. And then we also have a factor with the axial tilt of the Earth. So the Earth is always tilted about 23.5 degrees from the vertical line of the Earth. So true north and south is 23.5 degrees different than the magnetic poles. But as you can see in September and March, this axial tilt doesn't really affect the Earth. So that's when we're going to have the equinoxes. And then in December and June, the tilt is at its extremist. So in December, the northern hemisphere is pointed away from the sun, and that's when winter solstice occurs. And then the opposite is in June, is when the North Pole is pointed closer to the sun, getting more sunlight, and that is when the summer solstice occurs in the northern hemisphere. So on page 30, there's a couple tables and questions talking about observer's latitude, date, sun's declination, arc distance, and then sun's elevation. So observers' latitude is always given, and it represents this red dot on this green circle. They're going to place it in multiple locations, but it just realize that that is where the observer is located on Earth. Then the date is given, but you use that to find the sun's declination on figure 1.1 in your lab manual, such as this example on the right. And then arc distance is the observer's latitude minus the sun's declination. And then sun's elevation is 90 degrees minus the arc distance. So with that, you're going to fill out these tables and hopefully not have too hard of a time once you figure out kind of what they are asking. So the solstices, solstices are either the longest or shortest days, depending on if you're in the northern or southern hemispheres. So the summer solstice is the longest day in the northern hemisphere because the North Pole is slightly pointed toward the sun and it receives more daylight hours. It's going to be 23.5 degrees in tilt. And then the winter solstice is the exact opposite. So that's when the North Pole is pointing away from the sun. And it's going to receive the least amount of daylight hours. Equinoxes are when daylight hours is equal to nighttime hours. So that's in March and September. So latitude affects the seasons depending on where you are located on the Earth. So at the extremes, the North Pole and the South Pole, these are the high latitude regions, and then closer to the equator is the low latitude regions. So if you just think about it, Alaska has harsh winters, Chicago has somewhat harsh winters, and then Hawaii has pretty mild winters. So this is due to where they are located. Alaska is a high latitude area, so they're going to receive less daylight hours in the winter and receive more daylight hours in the summer. And then Hawaii is a lower latitude area, and they're going to receive somewhat consistent number of daylight hours throughout the year. So that's how they can have a jungle climate year round, and they mostly get 12 hours per day of daylight hours. So yeah, that's kind of a summary of Lab 3. Let me know if you have any questions. Thanks.